Well, hello there. So today our goal is to first try to understand the memory allocation in Linux and then move on probably to see how Go, some basics on Go probably. The slab allocator intended for kernel object with displaced. The unqueued slab allocator. So we had this there's memory managing. Memory management. Is it okay here? There's page frame management. This is fine. Descriptor. Uh, non body. Sequences. Memory cells having contiguous physical tree areas. But the system adopts page frame as basic area. Relatively large memory request. But how are we going to do it? It will be quite wasteful to allocate full page frame. Yes. The approach instead consists of integration. Describe how providing memory areas whose sizes are geometrically distributed. In other words, the size depends on power of 2 rather than on size of the data to be stored. No matter what the memory request size is, we can ensure internal fragmentation is running a memory area allocation on top of buddy algorithm is not better. Type of data to be stored may affect how commands on the form or initializes. Kernel functions tend to request memory area. Huh? Memory. Performance of entire. Schematically, the page frames used as dynamic memory. See the section physical memory layout. Figure 8.1. We have dynamic memory. This is where, okay, this is reserved for hardware. This is reserved for your kernel. See where it ends. This part is your dynamic memory. Chapter which consists of describes how for its own use page frame management and memory area management illustrate two different techniques for handling physically contiguous memory areas. Non-contiguous memory management. These sections cover topics such as memory zones, kernel mapping, the buddy system, the slab cache. That's the third technique, is it? Now, where are you covering the buddy? These sections, okay. So in the section, how Pentium processor can use 2 MB. Yeah. Linux adopts smaller page fault exception issues are easily interpreted. Either page requested exist, but other page does not exist. Second case, memory allocator must find a page fault. 4 KB and 4 MB are multiple page descriptors. Page descriptors. Kernel must keep track of current status of each page frame. For instance, it must be able to distinguish page frame in dynamic memory is free if it does not contain. Okay. It's not free if state information of page frame is kept in a page descriptor of type page. Fields are shown. This is a page descriptor for page frame. List contains pointer to least recently used. Don't have to fully understand usage reference for the page. Excuse me. If it is set to a value, flags. Access memory location to be same, but yes, that is not the same. Physical memory of the system is partitioned several nodes. However, the time might not be same for two different CPUs. For every CPU, the kernel tries to minimize number of accesses to costly nodes by selecting carefully where the kernel data structure that are most often referenced by. Okay, but do we need this? Like, why do we need this to manage memory? This is to assign those physical addresses to that CPU, like optimizing for the allocation, right? Not necessarily need this right now. Ideal DMA page frames below 16 megabytes. Page frame of memory 16 and 896. Page frame is memory storage unit that can be used for anything. Storing kernel, user, buffering data, every kind of page. Real architectures have hardware constraints that may limit. Particular Linux kernel must deal with two hardware constraints. DMA or old ISA buses have a strong limitation. They are able to address only first 16. CPU cannot directly access all physical memory. Fine. Cope with these two limitations. Zone normal. Why 896? This is like power 9 512 plus 250. Megabytes. So 4 times 520. What? 380 is it? Okay. 380. DM more and high memory. DMA zone includes page frame that can be used by old ISA. Right. To normal page frames that can be directly accessed by kernel through linear mapping in fourth gigabyte of linear. What? Normal page frames that can be directly accessed by kernel through linear mapping in fourth gigabyte. Right. Right. Because the C from here, how many addresses can we address? What can I subtract? this thing. Right. I still don't understand. Right. Oh, kernel can address only. Yeah, only this much. Right. So if I do this in the decimal, non-DMA that can be directly accessed by kernel through linear mapping in the fourth gigabyte. Yeah, basically, hmm, see, this is the offset. Now when it will be 896, yeah, it is higher of C section kernel page tables in chapter 2. Page tables for its own use rooted at master. After system initialization, never directly used by highest entries, ensures changes to PHP are propagated. Limited address space including kernel's code and data segments. 128 KB for some dynamic. In second phase, kernel takes advantage of all sets of page tables from. Yes, this is what we need to understand. Okay, let's go in detail. The provisional page global directory is initialized statically. Alright, this is what we are doing. We won't bother mentioning page upper and middle because they are equated to global. PAE support is not enabled. What was PAE? Page address extension. Physical address extension. access more than 4 gigs of by extending the okay. Provisional PGD is contained in the swapper page directory. The provisional page tables are stored starting from page 0 right after the end of kernels. For the sake of simplicity, let's assume that kernel segments and the 128 KB fit in the first 8 MB. Okay, first assumption, initial things fit into 8 or 4 MB. 8 was in Linux, 4 is in x86. Objective of first phase is allow 8 MB of RAM to be easily addressed in real mode and protected. Kernel must create mapping from linear through linear through 7. Okay. Kernel creates desired mapping by filling all except for 0, 1. Okay, why did I need to that was for the physical, right? 0 address field of 0 and is set to physical address of page 0, but the address field of Windows 1. Kernel creates desired mapping startup 32 assembly language function set the page bit. Okay. Final page table when RAM size is less than 896 MB. Final mapping provided by kernel page tables must transform linear. Uh, mm, mm. PA macro is used to convert linear to corresponding physical. Master kernel page global is stored in it is initialized page table init to set up. Its physical address. CPU supports PA sets actions performed by depend on amount of RAM less than Need to activate PAE. Swapper page directories. Cycle equivalent to the following. Returns PhD. CPU is user supervisor in PhD. Page size flag is set so that kernel can address RAM by making use of large pages. Page size flag. Where is the flag? Oh, so 1024 minus 128. 6 9, yeah, 128 MB. Okay, now I get it. That's for the video memory frame buffer things like that. Okay, which flag did you say? Page size. Set so that kernel can address the RAM by. Okay, we are not worried about that. TT mapping of first megabytes is required to complete initialization phase, and this mapping is no longer necessary by booking Zaplow mappings. Adjust the entries of page table corresponding to fix mapped linear addresses. RAM size is between this. Yeah, and we are not worried about that. Okay. Fields of zone descriptor. Pool of reserved. Quest can may otherwise some memory reclaiming. Okay, each page descriptor has link to memory node and zone inside the. Must specify the zones that contain the requested instance. So there is no way to ensure. Buddy system. Mm. Okay, we will carry on see these later. Now let us have a look at the GOLANG. For that, we'll just take a quick break. take a look at buff files. FMT's print line. Buff file. The scanner takes the file name, I guess. Your scanner takes in a IO reader, returns a scanner. Right. Make. What's make? Map of string int. OS standard input for each line in input dot scan. What is an iterator? Text return most written. Scan advances the scanner to next token. Very useful for compilation. For line if n greater than 1, fmt.printf %d. Parentheses are never used around the condition in an if statement. A map holds key set of key value pair. Constant associative map, right? Key may be of any type. The value may be of any type, but in this example, make creates an empty map. Maps are discussed. Okay. Each time loop reads a line of. I understand what's happening here. And value. Is it? Okay. Let me name the scanner. We are initializing it to buff IO dot scanner. Start std input scan on input text. Okay, scan text. Right, we are just incrementing that one. Can I? Okay, range of counts. Oh, for line comma n key comma value range. Okay, looks like range is range, not even a function, just a keyword. It's like an extent of something. What we will do here, we are gonna print even if print length. Okay, you have a printf as well, that's good. I'm gonna print key value. Can you do this? Hmm. 15 and 16. What? Sorry. Mm, braces. Map holds a set of key value pairs, provides constant time operation to store, retrieve, or test. Yeah, I've seen this. Line equal to input dot text. To print the results, we use another range-based for loop. This time over the okay, the first time you used was scan. Now you do a range. Also, the other for loop that we mentioned over here. Yeah, this was another. Okay, I see. Mm, in practice, it is random where I'm from. Design is intentional. Yeah, that is correct. Which helps make input and output efficient and convenient. One of its most useful feature is called type, called scanner. Lines or words, it's often the easiest way to process input that comes naturally. Lines. It's true. And I don't have to write a tokenizer myself. If I decide to build a new language, at least by program uses a short variable declaration. Create a new variable input that refers to above fields. Scanner reads from standard input. Scan function returns true if there is a line. New line character. Fine, this is fine. Okay. Was dot string length of. Okay, if you don't give any files, then otherwise for each file. Okay. Bio was that empty. Let's take the arguments. Stop arrays. Or in range. Is this the syntax? I keep forgetting. But what's the first value? Want to see what is this? And so I want to print. Want to open the file if error is not null. If error is not null, means there is some error. Otherwise, count lines. Okay, you name a variable and then give its type. File. I see. I can define the function anywhere. It doesn't have to be define or declare before use. Is it? Right. Empty.println. I want to read the file. Buffer buffalo.name. Previous one was okay. Here you will read the file. How do you read? Was can I specify a mode? Read mode, write mode, print mode. Okay, is nil. Then I'm gonna do this. Hmm. Contents of okay, for array, the first one is the iterator, it seems, or index. Then you're reading it line by line. Good enough. Second result of voice is a value of, yeah, some error in reading the file. Uh, more simple-minded error using f printf. Okay, reasonable or earlier and actually somewhat cavalier. We must check for an error from also. However, not places. We'll go to details of what is that call to count lines precedes its declaration. Okay, because you are compiling it in a different way. Map is a reference to data structure by a make. What? Map is passed to function. The function receives copy of the reference. Versions of the streaming mode. Entire input into memory in one big gulp. Split it to all lines and one. Okay, make the map for each file. Util read file. Strings dot split nodes. Okay. Under the covers, use read and write methods of. It's rare that programmers need access to those lower level routes directly. Higher level functions like buffer. Yeah, fine. Let's go for GIFs. Image packages, sequence of bitmapped images, then encode the sequence. Const declarations, struct types, composite literals. Stuff our example involves floating point computations. Primary goal is to give you an idea of what Go looks like. Hmm, amazing. Let's just investigate. It's just going to take the writer study out. Is equal to 5. Solution size and frames delay. Random dot float times relative frequency of y oscillator. GIF loop count and frames. Right. Looks like this creates a new class. GIF with how many frames we want. Then you have a phase difference, and for each you are adding a new frame in this loop. Image dot rect. Okay, you are creating a rectangle. Y2 times size image canvas minus size to plus size. New paletted for t equal to 0 to cycles 5 cycles times 2 times math pi sine of t y equal to pend anim dot image, yeah, set color index k. Nice, good for image processing stuff, huh? Let me just there's the funk. Angular resolution, one more. So easy to understand the code as well. Const declaration gives names to constant. Fixed at compile times. Expression like color, GIF, composite literals. Hold on, man. Use names. This is fine. You're at package level. Expression, this thing, composite literals. For instantiating pose composite types from sequence of element values. This color I saw, yeah, palette, white or black. GIF. Okay, these are composite literals, like their way of doing OOP seems. Is a slice and the second one is a struct. A type GIF is a struct type. A struct is a group of fields of that are collected together. The variable name is struct. Struct literal creates struct value whose loop on field is set to n frames. All other fields have zero value for their type. Individual fields a struct can be accessed using dot notation. Fine, this is fine. And produce images in multiple colors by adding more values. Fetching a URL. Yeah, it's good. Fetching URLs concurrently. Good for implementing a server. A web server. Yeah, it led to that. Good. Okay, I can use this instead of C# for my Vim server, right? Why do I need freaking C#? Have good file system handling. Okay, HTTP. Look at it a bit later. Loose ends. Lot more to go with Go. There are some topics we'll briefly touch upon. We barely touched upon. Enough discussion. Yeah, control flow. Tagless switch. Wow, name the types. Pointers. Unconstrained in other languages. There's not much that can be done with them except pass them around. Go to exposition. Address star retrieves. There's no pointer arithmetic, right? Methods and interfaces. Method is a function associated with the name type. Go is unusual in that methods may be attached to almost any named type. That's are covered in chapter 6. Interfaces are abstract, right? Just on what methods they have, not how they are represented. Packages. Programming is often more about using existing. Many more we don't have. For embark, it's a good idea to see. Index of standard library packages that file CMP crypto database. It's a SQL currently. Nice. Embed errors flag FMT HTML image IO log maps math mime at OS runtime strings. That's good. 2D. I guess games are a bit harder to do, right? Windows Portable. We already mentioned. Fine. Okay, program structure, declarations, variables. Okay. The goal is to write a functional compiler port of this project. So we had a GPU functional compiler. This one, right? We need to build a telco, an execution engine for lambda calculus. Okay, it's good enough. Thank you for watching. Bye.